All right, let's get started. Welcome, everyone, and thanks for joining us. This is Runway Analysis for Citation pilots. This is going to be a webinar on our brand new runway analysis capability and specifically how it can be used to enhance the flight planning for citation pilots in terms of making sure you can safely take off and land at any airport you're going to be flying into. So our presenters today are ForeFlight CEO and co-founder Tyson Weihs. He is a type-rated Citation 510 and M2 pilot. He probably doesn't need very much introduction, but Tyson, do you want to say anything quickly?
Yeah, hello everyone. Tyson from ForeFlight here. Good to be with you all. Looking forward to getting back in person, hopefully this year at CJP. Really excited about what the team has produced here. We've been working on this capability for a long time. I think the team has put together something exceptional. So we're going to walk you through how to use it and some of the finer points. But this is, I think, a real game changer for citation pilots that use ForeFlight, being able to work these calculations in. So thanks again for being with us.
Awesome. Thanks, Tyson. Next up, we've got Michael Vogt. He is the lead aircraft performance engineer and really the main person behind this entire capability. Michael, do you want to give a quick introduction?
Yeah, sure. Thanks, Sam. Yeah, my name is Michael. I've joined ForeFlight in 2015 as performance engineer. I've been an aircraft performance engineer since the late 1990s. I actually started my career at Cessna Flight Test back in the day, doing some flight test certification work, and also started CP Calc. So now you know who to blame on CP Calc. I joined another company later on and worked up another EFB performance software for that company as well. So I really enjoy all the aspects around aircraft performance and increasing the safety of pilots when it comes to aircraft performance topics.
Awesome. And third up here, we've got Josh Pava. He is a QA and product analyst at ForeFlight, and he is involved in a lot of different products that we've produced over the past couple of years. And he is a Challenger 605 and 650 pilot. Josh, anything you want to say?
Thanks a lot, Sam. Yeah, I think Sam, you pretty well covered it. I've worked with Michael and his team over the last year or so pretty extensively with Runway Analysis. I'm also involved with the review and approval process of all the procedures that are created in-house here at ForeFlight for engine out procedures. So I hope to be able to provide a little bit of commentary on, from a pilot perspective, how I use Runway Analysis and how it benefits us.
All right, sounds good. So real quickly with our agenda today, we're going to start out looking at some quick highlights of Runway Analysis that Tyson will go over and how it fits in our overall product offerings and what pilots can really expect from it. Next up, Michael will kick us off with a demonstration of the initial aircraft setup. There's very little required with Runway Analysis, but there are just a couple things you want to check. Then we'll go into some example flights planned using Runway Analysis, and we'll do a couple of different flights just to demonstrate the different modalities of this feature and the different kinds of flights it can be used on. And lastly, we'll take a look at where you can purchase Runway Analysis and where you can get support for it. And finally, we will have some Q&A. So before we begin, just a couple of reminders about GoToWebinar. If you want to ask any questions, you can do so via the message panel on the right. We encourage you to ask questions at any time during the presentation. Please don't wait until the very end to pose your question, because then it may not be answered. It's much more likely to be answered if you just type it in and send it whenever it pops into your head. We will be responding to those questions during the presentation, and then we'll pick out a few good ones at the end for live Q&A. If you have any audio problems, we recommend joining from a computer, not a mobile device. We just find that they tend to GoToWebinar performs better on a computer than a mobile device. But if you are having audio problems, you can try refreshing the browser or leaving and rejoining the webinar. And lastly, the session is being recorded and it will be accessible at foreflight.com/onfrequency. So Tyson, do you want to go ahead and kick us off with an introduction here?
Yeah, Sam, let's talk a little bit about some of the key highlights from the Runway Analysis capability that we've built. And you can go to the first slide here and I'll just walk through some of those key bullets. The first thing I think that's really important to mention about what we've done here is we've built a fully integrated capability. The approach we've taken is we've built our own proprietary engine, not only for building and producing the field performance calculations, but we've built all of our own technology for generating engine out procedures as well. And so that gives us a unique ability to cover and make changes to procedures around the world as we need to. We also include, because of our relationship with Boeing, the Jeppesen procedures for engine out as well. So, the initial version of the application comes with a really broad set of those. The integration is done inside of the flights view. And what's great about that is if you've been planning flights with ForeFlight, when you update your passenger counts or your load or update your route, all of those values then flow directly into any of the takeoff or landing calculations. We do some smart things on either the takeoff and landing views based on the type of airport you're going into and weather conditions. For example, if you're going into a single runway, an airport with a single runway, we can help auto select the best fit runway for that as well. But as you go back and forth between the flights view and make changes and any of the takeoff or landing views, we're round tripping those applications between each of those. And for many of us that have used applications like CESNAV, we understand sort of the hitches that are created when you switch from, ForeFlight to CESNAV and back and forth. And, this really helps keep those any values that you enter moving back and forth between those views. The second thing to point out is all of our data is sourced from aircraft manufacturers. So, we've partnered here with Textron and pulled their aircraft performance data into the application. So, the same data that powers Cessna's own applications is in the ForeFlight application as well. And I think that's really key to understanding, how we get to matching values and the precision there. As I've been flying the M2, during testing this, constantly do calculations with the FMS and with the ForeFlight application just to make sure everything was synced up there, and it's really great to see all of that match as well. The other I think bullet to point out is we're providing maximum takeoff weight and landing weight solutions for a range of different constraints, right? And so as you modify runway and runway slope or the aircraft weight, we're going to tell you when all sorts of limits are hit. So one of the things I have experienced out flying frequently with short legs and flying into mountainous airports are simple things like tailwind limit exceedances, but also brake energy limit or go around procedure limitations as well. So you'll see all those errors pop up in the application as you exceed those. I mentioned the engine out procedures that we've got available, and Michael's going to go into a bit more detail around some of the capabilities that we have there. And also the last one is it's meeting Part 135 takeoff requirements. We've integrated things like safety distance factors and whatnot, and I'm using 1.67 for example as just a standard operating procedure to make sure I've got enough room. But those are some of the highlights of the capability. So again, I think it can really help us improve safety, make these calculations a lot easier to do. You can do them from your phone now, which I think is a first ever capability, which is, you can be walking out to the airplane, you can adjust a weight, and you can see, the results of those calculations right from your iPhone, which is fantastic. I know Mark posted on the forum about a session he had with a contaminated runway. And what the impacts of a certain water depth would be, and did all that from his mobile device, which is really cool. So those are some of the highlights, Sam.
Thanks, Tyson. All right, so Michael, if you want to go ahead and kick us off with your demonstration, go right ahead.
Yeah, sure thing. Thanks, Sam. I'm basically going to set up an M2 real quick, and I think everyone knows how quickly that is done. I go to more in aircraft, and what I'm going to do is search on the M2 under aircraft type, which would be a C25M. I find it most helpful to search using the ICAO code, and you'll see right here that it supports runway analysis, so that's the blue label you want to look for there. Now, when I select that, I have to give it a tail number, of course. And there are two things I want to point out here with an aircraft that supports runway analysis, and it's towards the bottom of the screen, there's this performance group. We have 3 rows. The first one, performance profiles, is your standard cruise performance profile entry point. The second one's important to note. If you have an aircraft, or if you have an aircraft configured where multiple serial number ranges might apply to different types of aircraft performance. Now, currently, the first aircraft that will support this is actually going to be the CJ2 Plus. I'm working on that one right now, but the CJ2 Plus has 2 configuration codes, AD and AE. And depending on an application of a service bulletin, in addition to a serial number range, you will have to select one or the other for your particular aircraft. Now, the M2 only has a single group, and these are the serial numbers that cover that, but be sure to check to make sure you have the appropriate selection for your aircraft. And below the runway profile, we have this field performance section. Now, tapping on that allows you to go into a view where you can set your default settings. So Tyson mentioned, for example, he has changed his landing factor at the very bottom there from a standard default 1.0 to 1.67. And by doing that, every time that Tyson loads a new flight, every landing will automatically have that 1.67 as your default factor set. So if you have certain inputs that you want to default, this is where you change them, and this is where you basically set and forget them. And that's really all there is to it, to the aircraft setup.
Hey, Michael, I saw you had a profile that said like weight and balance template available when you set up the aircraft for the M2.
Yes, correct. So weight and balance is coming. We have some airplanes that support that currently. We have not yet released it. We're still testing it, but it's not too far away, around the corner. And that's it for the aircraft setup, Sam.
Awesome, thanks. Do you want to go ahead and walk through the first of the demos that you're going to be doing, the flight demos?
Sure thing. So this will be a basic demo from Myrtle Beach to Lakefront in New Orleans. And I'm going to select that M2 that I just created. I think everyone's familiar with the overall flights view here. So we have our flight selected. I'm going to add a couple more passengers in here to make it a little heavier. And the entry point is going to be at the very top here on the departure row. We have this takeoff button. And by tapping on the takeoff button, it brings me into the view for my takeoff procedure. And what you see right away is it already auto-selected a runway for me based on the current wind conditions. So we have a southerly wind situation, and it shows me with a green arrow, I have an 8-knot headwind component from the METAR, so it selected runway 18. At the very top, we have the header. The header is kind of the static portion of this view. So as I scroll, the header is always in view. And from left to right, you have your planned takeoff weights, a little bit over 10,000 pounds here. You have your takeoff field length, about 2,763 feet. You have your V speeds, V1, VR, V2, and your en route speed. And at the far right, we have our level off altitude. The level off altitude is the target altitude that you would level off at after losing an engine just prior to V1. Because remember, we're using AFM data, and all the AFM data is predicated on the fact that you lose an engine just prior to reaching V1. So all the climb information and the performance speeds and the runway, it's all predicated on the fact that you have lost an engine. So that's key element right here. A couple things, we check various constraints. So for example, we have a 2760 takeoff field length. If I shorten the runway to, for example, to 2,700 feet, you're now going to see this red banner on top saying that you have exceeded your TORA or your ASDA. In other words, your declared distances by 64 feet. But also notice in the header, we have this subline, this subtext line. It's called max takeoff weight. And my max takeoff weight now has dropped to 9,937 pounds, and I'm runway limited. So it's telling me what the limitation reason is. And the reason is my runway is too short at 2,700 feet to take off at 10,050 pounds. So I'd have to reduce my weight to 9,940 pounds in order to successfully make it off that runway. In addition, we have additional checks built in here, brake energy limits, and some aircraft have tire speeds and things like that. So whatever the AFM produces in terms of limitation checks, we have those included in this analysis here. I'm not going to talk about the obstacle analysis portion. I want to highlight that with a different airport later on. Scrolling to the bottom here, you'll see we have an aircraft configuration section. Each aircraft will have a different list here, of course. but we typically provide whatever is in the AFM here. And just below that, you have your emergency return. So as you're planning your takeoff, you can actually do a landing analysis to the exact same airport, and it will give you an idea if you are going to be safe or not. So this is the one place where we allow you to exceed your maximum landing weight, and the reason is you may not have a choice. So we will warn you on the fact that you are exceeding your maximum landing weights, and maybe you want to, if you can, be a little bit lighter on the braking or something like that. But basically, this gives you the performance numbers for your emergency return for landing to that same airport. And at the very bottom, we show the performance information. A lot of the information is repeated from the header, but there is some additional information here. You can see your first and second segment net gradients, for example, which give you an idea of your climb capability. Once again, these are climb gradients with one engine inoperative. It's always important to remember that. All right, before I hand it off to Tyson to do another demo on an Aspen flight, I want to talk about a couple things that are on Josh's and my mind. So one thing to realize is on the takeoff data is how the AFM data is generated. And I think, Josh, you might be best to talk about that as a pilot. So go for it.
Yeah, sure. Thanks, Michael. So the takeoff numbers that we generate, or for that matter, the AFM generates, are numbers that are based on a predicated set of circumstances. Where I'm based, we're often runway limited, meaning the runway length is our controlling factor. And so when I do a takeoff that is at the balanced field length, I need to know, how do I achieve this performance? How am I going to be able to meet the objectives that are set by saying I need this much runway and do it safely? So when you reference the AFM, oftentimes they'll tell us what, or actually every time they'll tell you what are the circumstances, the scenario to be able to extract the performance that we're promising you. In the case of a Citation, it's a static takeoff, meaning you're standing on the brakes, absolutely zero ground speed. You're bringing the throttles up to take off power, then you are releasing the brakes. So if you don't do that, you cannot expect to make the runway numbers that are being generated within this view.
That's a great point. And along those lines, something else to keep in mind is any runway behind you is kind of lost runway. So when you're standing on your brakes, you're at your brake release point. You want to be obviously at the end of the runway, the full length of the runway. We have here showing usable length, and this is the full length of the runway. By the way, we show usable length if all the declared distances are identical, which is in this case, if you select an airport and a runway where your TORA differs from your ASDA, we will list each one individually. But the other thing I want to point out is the lineup allowance. The lineup allowance is here essentially for larger jets. So if you fly a large Gulfstream and you have to make that 90-degree turn from the taxiway onto the runway, you might lose 100 feet. You might lose 150 feet behind you that you cannot make use of. So you can actually account for that if you wanted to, for example, do an intersection takeoff and you know how much distance is behind you. That's another way to do that. But what Josh says, it's crucial. You have to follow the AFM procedures of standing on the brakes, bringing it up to static takeoff thrust before brake release. Otherwise, you will not achieve these numbers. And in line with that, there's a similar discussion on landing. So the landing distance information here, if I flip back to a 1.0 landing factor, you'll note in the header, we list it as an actual distance. And if you go into the AFM, you'll read that the actual landing distance is calculated from a 50-foot screen height using a 3-degree flight path angle to touchdown with little or no flare. Now, most or many pilots probably do not perform such landings. They probably come in a little bit shallower. They might have a little flare that they carry. They might carry a little extra speed than VREF. And some flight departments actually have SOPs where they will add 500 feet to whatever the actual landing distance is given. So I think it's important to realize that the actual landing distance provided by the AFM is your best case scenario. And it's also why you want to make use of these landing factors. The 1.25 and the 1.44, they're equivalent to dry and wet 80% landing factors that 91K operators typically use. Some 135 operators can make use of that as well. And the 1.67, 1.92 factors, they're the 60% dry and wet factors. Now, what does that mean? If I use a 1.67, which is equivalent to a 60% dry factor, I'm ensuring that my calculated landing distance fits on 60% of the available runway or 60% of the LDA, but only if I fly the landing, as I previously mentioned, without flare, without hitting that 3 degree flight path angle and so on. And Josh, how often do you fly? I'm not going to say carrier style landing because that's not what it is, but how often do you fly the perfect landing approach into the flare, into the touchdown? Does that happen a lot to you?
It doesn't, Michael. And I've flown with a number of different flight departments, a number of different crews, and I'll tell you, other than watching, the flight test folks do it in Wichita when they're testing new airplanes, you really do not see the sort of touchdown that's required to get these numbers on a day-to-day basis. Most of us take a lot of pride in how we fly, specifically how we land. And if you want to do a greaser landing, you're probably not landing in the way that the AFM certification data is requiring you to do so. So from an operational standpoint, landing factors are a great thing. If you see that you cannot land with that 1.67 factor, for example, pretty good idea that you might need to either consider a different runway or really make sure you're flying exactly by the numbers. But as Michael said, it's essentially based on no flare. So, most aircraft, 50 feet, you're going to idle, you're at VREF, and you're doing a slight arrest of the descent, but that's all you're doing. I was speaking to a pilot recently who brought up the point saying, I always beat my AFM numbers on landing. So it says I need 2,300, but I know I can stop in 1,300 feet. And the reason why he says that is because he's probably not crossing the runway at 50 feet. Perhaps he's going to idle a little bit sooner. He's probably shooting for the runway numbers, not the touchdown zone. So many, many factors can go into beating those numbers. But when it comes to flying the airplane by the book and making book numbers, it pretty much requires you to fly exactly the profile that's specified in the AFM. And as Michael say, essentially it's a carrier style landing where you're focused on doing a constant descent onto the runway, and you're not trying to win a landing contest that day.
Yeah. And I think passenger comfort might come into play too here. I mean, I'd imagine you don't want to, hit the runway too hard in order for passengers to be somewhat comfortable with the landing. Does that come into play at all?
Yeah, absolutely. For those that do fly with passengers quite often, the passengers really are not interested in feeling carrier landings for the most part. So, I think we all take pride in what we're doing, and a carrier landing is not something that we take a lot of pride in doing very often. So, absolutely passenger comfort, but as sort of a professional pilot who carries passengers, my stance is it's always a lot more impressive to stop on the runway than overrun the runway, but you had a greaser landing.
Yeah, it makes total sense. There's one more thing I want to mention on these landing factors. So the 60 and 80% landing factor calculation is really based on the fact that you select a dry actual landing distance as your basis. Now, we are not locking you down to that. You can take a wet condition and factor that as well. It's just going to provide additional safety. But really, these 60 and 80% factors that we provide here as a or not as a default, but as an option, are really meant to be used with a dry base landing distance. Now, also note on the very bottom, we have a custom factor ability. So something to maybe look up is SAFO 19001. I think back in 2019, FAA came out with SAFO 19001, and a few pages down, they provide a table of landing factors that you can use based off of different aircraft types and different runway condition codes. For those of you who are not familiar with runway condition codes, it's part of the RCAM matrix. It is based off of the FICON code that's provided, I think since 2016 or 17. And as of November this year, it's going to be required globally because the ICAO is introducing the Global Reporting Format, GRF. And really, you're going to see FICONs everywhere being used. Now, the aircraft manufacturers are starting to provide us with RCC code performance data, and we will update our aircraft models to include those as we receive that. So if you look at SAFO 19001, there will be a list of factors that you can apply, and you can use this custom factor inputs in order to do those. So some of them, I recall there's a 2.4 factor, and you can use your custom factor to set 2.4, and now you'll notice in the header here, our factor distance has increased to 5,200 feet. So make sure you use a custom factor if needed, and eventually we'll be able to provide the RCC code effects on your landing performance as the aircraft manufacturers provides that data to us. And I think with that, I want to pass it back to Tyson.
All right. So as I mentioned earlier, I've been using this feature a lot, and I thought I'd walk through scenarios, some scenarios that I've experienced, and some of the limits that I've seen. So I'm going to just plan a flight here from Austin Executive to Aspen, Colorado, and then play around with some of the inputs so you can see how those affect the calculations. So first, I'm going to, obviously as Michael did, and as many of you know, entering departure destination is pretty simple. I'm going to come to Aspen here. I'm going to go ahead and load up a route, so I'm getting a realistic route. That looks like one that's common. Put 4 people on board the airplane while I had 200 pounds of cargo. And we're going to use max fuel in case we're slowed down or holding. Okay, and then I'm going to go ahead and do the takeoff calculation. So going into the takeoff view and adding a bit more color around what Michael presented, I'll go ahead and start with the runway. And as you can see here, we've highlighted the wind components of runway. So that's going to help with runway selection as well. And so I'm going to take runway 31 here out of Austin. And one thing to note is, we use this blue color to indicate anything that's changeable in the application. So for example, if for some reason the field length was shortened from 60-25 via NOTAM, I could make that adjustment. If I wanted to add a lineup allowance, say I'm going to taxi, 20, 30 feet into the runway, I can add that as well. The slope is adjustable, and the reason why we made that adjustable is we might not have some runways slope information. So in the event that we do have that from the underlying navigation data from Jeppesen, for example, we'll automatically populate that. But if it's not there, again, it's something you can adjust. So there might be a private airport, for example, that you go into that doesn't have published slope information, and you may know that. And then surface condition as well. So we've got all of the surface conditions that are provided from us via Textron. So if we want to look at some contaminated situations like wet runway or snow or slush, for example, we can make those adjustments as well and see what those are. So I'm just going to assume it's a wet runway for today. And then in the obstacle analysis section, Michael said he's going to get into a bit more detail about that. But I'm just going to go ahead and select the EOP2 RNAV procedure. Now that's a ForeFlight constructed procedure, and today it's in text form, but we'll be inventing some interesting ways to use that in the future. So here I can see the textual description of the EOP, and I can modify the wind in the event that I need to. But we're going to automatically look at METARs, TAFs, and even our daily weather capability to try to auto-populate the weather for the time of arrival or time of departure. One thing that's helpful to note here is we have a toggle like you might see in for example, the G3000 FMS, where you can toggle between magnetic and true. I've seen some comments on the forums where people have been tripped up about this, and this is an important one to remember is when you need to use magnetic or true based on whether you're hearing a textual or a verbal description of the weather. And going into Aspen a lot, you might hear one weather reading on the radio, but you could call for static winds, for example, and get a different figure. And so you might want to adjust that from the METAR or TAF. And I've had to make those adjustments a number of times where, for example, there's a gusting tailwind going up 15 to 20 knots, but you get the static wind report and it's 9 knots, for example. So in that case, you would use that wind speed override as well. And I mentioned earlier in the intro about the round tripping between the flight's view and the takeoff and landing view. So here, if I look at my weight, I've got a max takeoff weight out of Austin. I can make those adjustments here, and if you make an adjustment on the flight's view, that weight is going to round trip into the takeoff view as well. So really nice to have that copying of values automatically into this view. And if I need to make any other adjustments to anti-ice, anti-skid, etc., those are available. Michael mentioned the emergency return, so no need to take a look at that. So I'm going to go into the landing view, and one of the things you've seen immediately is runway 15 was automatically selected. So in this case, Aspen's a single runway airport. 15 is typically the favored runway. That's the wind-favored runway as well today. It's calm winds, at least in the TAF, and you can see down here in the footer below the altimeter setting that we are loading in the TAF. We're going to tell you what weather information and source we're using when we load this. So, for example, if we loaded the METAR, you'd see that it loaded the METAR, the TAF, etc., and what the age of that weather is as well. So one of the things I mentioned is the ability to set the landing factor. So if I tap on this landing factor view, I get a number of different ones. I like to use 1.67 to provide enough margin there. So I've selected 1.67, and now we've got I mentioned the wind information. So if I wanted to go ahead and see what would things be like if I had the winds coming from 330, for example, which would be a tailwind. And let's say that's just at 15 knots. You can see the first error here is published, which is I've got a tailwind component of 15 knots exceeding the published limit of 10 knots. So going back to that scenario I mentioned earlier, where you might have a METAR TAF that's reporting gusting winds or winds different than static, this is where I would come in and make that adjustment, bring it down to 10 knots, and that disappears. Another thing I've run into, particularly in Aspen, is, and in really just flying in the mountains, flying both longer and shorter stage lengths, is brake energy. And so if you do have a short leg, the nice thing about having all of this integrated is you can run all the takeoff and landing calculations before you depart and really get a sense of whether or not you're going to be exceeding a limit. On those short legs, this is where that becomes really helpful. So I'm going to put 9,900 pounds here. So that is a max landing weight configuration, and you can see here that I'm seeing a couple things. One is with the 1.67, I've got a required landing distance exceedance, and then I also have a max weight exceedance due to a brake energy limit or a minimum climb requirement. Right. So this is one that you don't see that often in CESNAV, or at least I haven't seen it. But it catches your attention when you see this particular error. So just wanted to highlight that because that's the sort of type of constraint that we're able to produce. And if I want to go back to the predicted landing weight from the point of planning, like there's a little use button that says 8964. That was the weight that the flight plan had predicted for me upon arrival. And in the event that I have a contaminated runway, for example, I can use the VREF increment. So I'm going to go up here and I'm going to say, well, Aspen's a wet runway. You can see this. I'm starting to get into trouble with not only the wet runway, the 1.67 landing factor. I'll put that back to 1. That will be good. And then I'll adjust the VREF increment to plus 10 knots. Again, this highlights another important constraint, which is being on speed is pretty important in this particular calculation, given the current conditions, right? So I'm going to put that back to a VREF increment of 0, and we're going to change the runway back to dry. You can see there that when I had that VREF increment, it's pinning it to a wet runway. So you have to first unset the VREF increment and then update the surface condition. Another thing to highlight on this view in the upper right-hand corner is the summary. It's important not to miss that button, because what you get in the summary view is a really great analysis of the full flight, both the takeoff and landing information. And the other thing that's really nice here is the takeoff analysis and the landing analysis will go ahead and do the calculations for every runway. And I'll just scroll down to Aspen here. And the important thing about Aspen is if you happen to be needing to circle to 3-3, you're going to go ahead and have those calculations produced for you in the 3-3 column in the bottom right. So in the event I do need to circle, I've got still the 7,006 foot landing distance. I have a 2% downslope on that runway, so that's an important factor here. And then I can see my distances as well. So here you can see in the zero wind situation, I've got a 97.48 climb and brake energy limit, and I've got a 10 knot tailwind limit of 87.65. So that's really, coming into that 3-3 with that 2% downslope does provide a lot of limitations on that landing. So if I went ahead and said I'm going to land at, say, 9,800, which is below max landing weight, but it's going to create some challenges for me on runway 3-3. Yeah, something else I think that's important to mention to the summary is, say you want to save this information and have it for future reference, or to just save it permanently. There's a Send To button in the upper right-hand corner, and we've added this new option in this view, which says Send to Flights Files. So just under that copy item in the upper right, I'm going to hit Send to Flights Files. You can see the success check mark there. And what that means is if I go into this Files view with the little paperclip icon on it, I've got a saved copy of that PDF. Now, when I have that saved copy of the PDF, I get things like annotations. So if I wanted to highlight something specifically, I could do that as well. And those annotations will be saved along with that saved copy of the runway analysis. So if you wanted to do a few different scenarios and save them, you could make changes to either the takeoff and landing values, use that Send To button to store it to files, and you'll have multiple scenarios saved and referenceable later. So with that, that's just a quick and dirty view of an Austin to Aspen flight. If I want to do the return trip, I'm going to hit Add Next Flight down at the bottom. It's going to carry some of my values over to the next flight. We're going to go back to Austin Executive. And here I'm really just going to highlight the takeoff aspect of this. Again, I want to do max fuel. We want to really load up the airplane. So if I look at this, I've got 10.8 ramp weight and 10.7 takeoff weight. So that's max takeoff weight for the M2. Now if I go to takeoff, you can see takeoff impossible due to obstacles. Well, that's because I have a straight out procedure selected. So if I come in here and I'm going to do the select one of these EOPs, you can see that I've got for Aspen, Jeppesen, EOP1 with a max takeoff weight limit of 10.7 and an EOP2 as well. So I'm just going to go ahead and do EOP1 here, and I've got that procedure textually down below for the engine out procedure. One of the things we do that's unique in our engine out procedure design is we really try to pin the departure procedure to RNAV waypoints that either are on the SID or potentially already in your FMS with the departure program. So here we're going to Adney, Boyette, and Lens, and then doing our climb and the hold here. But the great point about this is I'm able to take off at 10.7 out of Aspen with this EOP here. So really get the full use of the airplane. So that procedure again is accessible to me under this engine out procedure view, and got all the V speeds I need and the level of altitude of 9,600, which is decently high above the Aspen airport. So Sam, I think that wraps for me. That's a quick view of the Austin to Aspen and back, and how we help improve not only the speed of these calculations, but all of the limitations and constraints that we alert you about along the way.
Perfect. Thanks for that, Tyson. Michael, do you want to go ahead and take over and show us one of your demos?
Yeah, sure. I want to dive a little deeper into the engine out procedure and kind of a little look under the hood in terms of what's going on there in terms of design, and also bring Josh in because he's integral into the design and approval of those procedures. So I'm going to hop over to the 3D view out of Eagle, and this is what it looks like runway 25 out of Eagle. Literally a couple miles off the end of the departure end of the runway for 25, you're faced with at least 2,000 foot elevation change that you would have to climb over if you want to do a straight out departure, which we also offer. But for those of you who have flown out of Eagle, you'll know there's a Beaver 1 departure, which takes you in this direction over lower terrain. And if you look at that departure procedure, it will actually state that the requirement, I believe, is 740 feet per nautical mile up to 10,200, which equates to about 12% climb gradient. And you look at the procedure here, you follow a few waypoints, and like Tyson mentioned, when we design our engine out procedures, we try to mimic the SID or the EOP, at least initially. And the reason is because, as Tyson mentioned, you will often have those procedures already pre-programmed into your FMS. Um, so what I'd like to do actually, Sam, if you can flip over to the Google Earth image. Okay, it's already up there, great. So this kind of shows you a little bit about how we design these procedures. We have some fairly sophisticated software developed in-house to aid us in identifying procedures. Now this one was probably an easier design because the SID already shows us a great lateral path. What we're showing here is the blue corridor that you're going to see is based off of the AC 120-91A recommended guideline from the FAA. So 20, 30 years ago, there's always been this discrepancy. Do I need to meet chirps climb requirements if I lose an engine? And in the 2000s, the FAA came out with AC 120-91A to define recommended guidelines on how to develop engine out procedures. So we follow those. We develop this path here, and all the obstacles that are inside that blue corridor are included in the engine out departure procedure and are considered during the runway analysis. The TERPs, however, so your SID and your ODPs, they cast a much wider net across the terrain. They're looking at obstacles 1 or even 2 miles laterally offset from the central line of this path here. And because of that, you end up with a high required climb gradient of 12%. Now, if you lose an engine, you're in an emergency situation. You do not need to climb 12% with one engine operative. So if you follow this lateral path here and you maintain V2, we keep you above the terrain and above the obstacles. I think at this point, Josh, as a pilot, I'm kind of curious to hear from you what your thoughts are. And also, since you approve these procedures, what kind of observations have you had?
Thanks, Michael. So, as you mentioned, I approve many of the procedures that we develop in-house for our engine out. And what we're looking at with this sort of procedure is a reality check of can it be flown and how will a pilot fly it. So this procedure is designed to be flown at V2 and then enter holding once you get to your holding fix, and you're going to hold with right turns. So what we're looking at when we design this is, like I said, is flyability, but also where are the obstacles and what's the best place for the aircraft to be flying, as compared to TERPs or as compared to the published procedure. Being engine out, we're allowed a much tighter corridor for obstacles, and with that corridor in mind, we're able to pretty tightly refine exactly where we want the aircraft to go, where we want it to hold, what speed we want it to fly. And when we design and analyze these procedures, we're designing essentially a maximum indicated airspeed for this procedure. And you're going to find that textually given to you both in the EOP summary and the EOP select your tab in the flights view. Is there anything in particular you want me to hit with this, Michael, beyond that?
No, I think that covers it. So if you want to switch over to my iPad, Sam, I just want to show real quick. I have the engine out procedure loaded here for Eagle, and if I tap on the selection here, the maximum takeoff weights for each of the 3 procedures kind of gives you an idea of the capability. So we're throwing the aircraft performance capability against the 3 different procedures, and you'll see right away that the RNAV one that follows the waypoints is is the one that provides you the highest weight. And like Josh mentioned, because we're focusing on a much narrower corridor per that AC 120-91A, we are not considering all the obstacles that the TERPS considers. And I really like how we calculate this on the fly. I don't think anyone else does this right now. So you can visually see very quickly that, this is the one I want to choose. And in this case, it does follow the SID, so you probably already have it programmed into your FMS. So definitely keep an eye out on those maximum takeoff weights. And, if there's a reason to choose one of the other ones, go for it. But typically you want to optimize your maximum takeoff weight for the highest value. So Josh, as a pilot, I want to hear from you. What are your thoughts about the different engine out procedure selection here, and which type would you select under which circumstances?
So when I get the opportunity to review the EOP list that we present, of course, I'm looking at the maximum allowable takeoff weight for each EOP, but I'm also reviewing what the EOP has me doing. In some cases, EOP has us doing a series of small turns that essentially reverses course. Other times, it's pretty much a straight out departure to hold. If it's cases that it's a straight out departure or very few turns to hold, I'm probably going to prefer that if it gives me a higher maximum takeoff weight. But on the other hand, knowing that in the event that the EOP has some turns to it, we take a performance hit. In other words, that turn, which of course we lose some lift in the turn, causes us a penalty. So in some cases, either from a penalty standpoint or just from an ease of flyability standpoint, the straight out procedure may be the best choice. It's certainly simple to essentially fly a runway heading, to be departing a runway and have to do an RNAV EOP, which may involve switching flight plan waypoints at a time where you have your hands full. It may not be ideal in some cases. So if I can possibly depart straight out and it works for my flight scenario, the majority of the time I'm going to choose that just because it's so easy to do and it requires the least amount of effort and the least amount of change at an already very high workload period.
Now, that makes a lot of sense. And thinking back to some of the other procedures that we have designed, some of these procedures only follow the SID for maybe the first portion of that SID, and then we kind of veer off of the SID because we're targeting lower terrain where the SID takes you over higher terrain. I remember there was a case in Phoenix, I believe, where that made sense to depart the SID. So without having to think about these additional complexities, it does make sense. Can I just maintain runway heading, keep flying straight, focus on maintaining V2 to my level off altitude, and immediately the flyability has become so much easier. So that makes a lot of sense.
Yeah, and I've also found during the design and the review process of the EOPs, most of the time we can stay with the departure procedure if there are some pretty close-in fixes. But the further out that the departure procedure takes you, the less likely it is that we're going to be able to stay with that departure. So you're absolutely right, Michael. Everything you said, it rings very, very true.
And one other thing to note on the straight outs is for the turning engine out procedures, we actually look at the entire track, the entire path into the holding pattern. For the straight outs, however, we look at a minimum of 20 nautical miles out. So for this particular one, you're limited to under 13,000 pounds, quite possibly because of a mountain range 8, 12, 15 miles down range. And hopefully by the time you get to that altitude and that location, hopefully you'll be in VMC conditions and you can actually see the mountain peak at that point. But we look way far down range in order to provide that safety on a straight out. So that's something else to keep in mind. And yeah, I think that's all I had to say to that.
Yeah, and my goal on an EOP or a straight, an RNAV EOP or a straight out departure is really so I can get in radar contact, get within the controller's MVA, and then the controller's gonna be able to vector me where they want me to go. I've declared an emergency, and such that I'm in a much safer time zone, or much safer area, I should say. So,
okay.
Yeah, go ahead.
No, I was just listening to how that works in real world. That's interesting.
Yeah, so once the aircraft has declared the emergency and you're within the controller's minimum vectoring altitude, the controller then is able to start working you vectors back to the airport or back to an emergency return airport, which may or may not be your departure airport. So my goal when I'm flying an EOP is really to get into the minimum vectoring altitude of air traffic control such that they're able to send me where they want to, and they're taking control of obstacle and terrain separation requirements that I have my hands full trying to meet.
Nice.
All right, thanks. So before we move on to Q&A, I just want to cover a couple of quick pieces of information about how you can purchase Runway Analysis and where you can find support for it. Individual accounts can purchase Runway Analysis for the 6 Citation aircraft that we're currently supported directly through ForeFlight. You just go to foreflight.com/buy, you sign into your account, and you make sure that the Performance Plus is selected on the buy page. Of course, Runway Analysis requires Performance Plus, otherwise it wouldn't have the performance data necessary to do those calculations. So when you select performance, you can scroll down the page, and then there will be a module that you can expand with the different runway analysis selections that you can make. Now, if you're part of a group account, a ForeFlight business account, then you will have to contact our sales team to talk with them about making this purchase. And we've set up a very convenient form that you can fill out. And if you go to foreflight.com/RWA-form, you can fill out that form. It'll go straight to our sales team, and they will arrange a live demo to walk you through the product and discuss purchasing. We also have a very nice runway analysis support page that Michael helped us build with lots of very detailed breakdown of all the different types of information you can find, and a really thorough FAQ on that page. So that's at /RWA-support. And finally, you can register for other webinars, and you can watch this webinar as well as many other past webinars if you go to foreflight.com/onfrequency. So let's move on to some questions. So first up, first question here, is the citation performance data sourced from the AFM or the CESNAV database? Cessna advertises optimized performance, quote unquote, using CPCalc. How much of an advantage is it really using CPCalc? Any plans to add additional performance capabilities from CPCalc, such as climb profiles and single engine drift down? Michael, are you online to take that question?
I am. Can you hear me?
Yep, loud and clear.
All right, awesome. A lot of questions here. Thank you for that question. So the important thing to remember is CPCalc is what's known as a first principles calculation software, meaning that Textron, as the OEM, has the capability to do essentially F equals MA type calculations based on aero models and thrust models. So CPCalc will always provide the most benefit, I guess, or the most, really the most capability out of your calculations. Now, when the FM data is created, it uses the exact same source data, and we are working with Textron to provide as close as possible solution to CPCalc. So there might be some edge cases where you can have slight higher maximum takeoff weight results or solutions with CPCalc. However, what you lose compared to us is obviously the fully integrated capabilities. We can do obviously the flight planning. To answer several questions about weight and balance, yes, it is coming. It's actually not that far off in the future. So we're going to be able to have the capability to cover all 3 tiers, weight and balance, flight planning, as well as runway analysis in a single solution. They will all check each other, and make sure that you're within limits of everything else. Now, CPCalc does have the ability to create or to calculate some additional components such as drift down. I believe it also has the all engine climb capability for your SID checks, your maximum, or not your maximum, but your climb grading requirements for SID and ODPs. That's all on the table in the future. We really have not had any discussions around that, supporting that right now. We're kind of focusing on the runway analysis components only, but we could definitely in the future as an add it in there if we wanted to, or if Textron allows us to do so. So hopefully that gives you a little bit better idea about the capabilities of our solution versus CPCalc.
Awesome. And you already addressed the question about weight and balance, so I'll skip over that one. Next one up then is, for Part 135 operators, does your service require an approved FAA approval? Michael, can you respond to that one as well?
So first of all, I'm not an expert here, but from what I understand from the customers is that 135 operators, they need to provide to their FAA POI, I think Principal Operations Inspector, They basically need to provide to them the evidence, essentially, that whatever software solution they use is satisfactory to that POI. That's the way I understand it. So it's really up to each individual 135 operator to make sure that happens.
All right, thanks, Michael. Next question. Any plans to overlay more engine out procedures on more of the departure procedures? For instance, APG has 4 or 5 options in Aspen, and some were overlaid on all of the popular departure procedures, enabling the same plan to be used engine out versus normal. Josh, are you available to take that one?
Yeah, absolutely. Thanks, Sam. We are constantly adding additional procedures to our EOP database. And so, said another way, what you see today is only the start of what you'll see in the future. During the creation of our EOPs, we do our best to mirror existing published procedures. Sometimes that's not possible to do. If there's terrain obstacles that are, conflicting with single engine performance, then we have to take the aircraft off of the published procedure much sooner in our own EOP than we would in other cases. But the short answer is, if it's advantageous from a terrain and obstacle standpoint, we're going to leave you, at least in the beginning of the procedure, on the published procedure. If we cannot do that, then we're going to try to make a procedure that's as simple as possible for the pilot to follow. My goal as I look through these procedures, as I design these procedures, is I'm trying to design a procedure that can be flown with minimal changes in the cockpit. It's already busy enough when you're after V1, you've lost an engine, and now you have to transition onto a new procedure that you weren't planning on. So, simplicity is the goal for all of us that are designing these procedures. And if it's possible and safe to do so, we're going to leave you on those procedures as long as possible.
Thanks, Josh. Another question for you here. How are aircraft weight changes controlled across multiple iPads on the same subscription?
So if you make a change to the weight that is, passengers, cargo, fuel, any, assuming we're talking individual account here, any changes that are made on that flight are synced across all of your iOS devices. So said another way, if I'm using my iPhone and I decide to increase my fuel or add a passenger, that weight change is going to sync to my iPad as well. And that data is used in our takeoff and landing configuration to calculate the baseline numbers that we come up with.
Great. Next question here is, at airports in Southern California, at times, straight out departure after engine failure may not be possible. Does the runway analysis provide for turns to avoid congested airspace? And Josh, I believe you fly in Southern California occasionally. Do you have an answer to that?
I do. So this is a fantastic question, one I can relate to very, very well and understand exactly what this question is getting at. So the short answer I can give you on this is, during our design phase, we do try our best to avoid airspace that would be undesirable to fly through. So probably our most critical airspace that we're trying to avoid is restricted airspace. A lot of restricted airspace has military activity, potentially bombings going on. We really don't want to send you through that airspace. On the other hand, if we're talking, class Bravo, class Charlie, class Delta airspace, an adjacent airport, we're less concerned about that. By the time you've lost an engine, the pilot's going to declare an emergency. Air traffic control is going to get on their landline and tell, say you're departing Long Beach, they're going to tell Torrance, stop all departures, or LAX, stop all arrivals, whatever is necessary. So once a pilot has declared an emergency, airspace should be really probably the least of their concerns. Air traffic control is going to take care of that for you. So our goal is safety, not avoiding airspace. But of course, we're going to keep in mind, when there's absolutely critical airspace that you should not penetrate, our procedures are not going to go through that.
All right, next question. Is there an option to provide an expanded temperature versus weight limit table beyond just plus or minus 2 degrees in the summary view? APG provides an option for a full range of temperatures, which is very useful for flight planning a few days in advance when the exact temperature isn't yet known. JP or Josh, can you take that one as well?
Yeah, sure. So we are using our daily weather for sort of distant forecasts. You know, 5 days away, maybe you're running performance for. We're using our daily weather feature for that, which does have temperature. And while I can definitely relate to what the question is about regarding APG, I think our solution is potentially as or more elegant in that when you're in the takeoff or landing summary page for the flight, you're able to actually set a temperature. So if you want to do a what if scenario for, let's say Aspen, and you want to see what it's like at 18 degrees, you simply enter 18 degrees on the takeoff page, and right away we calculate a new maximum takeoff weight with what the limitation is. If you then say, well, maybe it's going to be 25 degrees, you enter 25 degrees, and instantly, and when I say instant, I'm talking within a second, you get a new maximum takeoff weight and a new limitation reason, if there is one. If there is a new one, that is. So I understand the comparison. However, I would say our ForeFlight presentation is, from my perspective, easier and quicker to use and allows a lot larger of areas for collecting data at a short period of time.
All right, thanks, Josh. Another question here. Let's see. We currently use AirInc Direct for our XLS Plus with APG for runway analysis. How is your engine different, and why should we switch to ForeFlight's runway analysis engine? Michael, are you available to respond to that one?
Yeah, sure. So in terms of how is the engine different, I have zero insight on how our competitors do their business, obviously. But from what I've seen, everyone uses the same AC 120-91A, which is the airport obstacle analysis AC from the FAA as their guideline, and we use that one as well. So I'd highly recommend reading through it and kind of become familiar with what's in that AC. But basically, it's a definition of the obstacle corridor to consider for EOPs. So really, everyone should be doing the exact same thing, using the exact same aircraft performance data. I mentioned previously, I feel like where ForeFlight shines is really the fact that we are striving to have a fully integrated solution. You have your weight and balance pretty soon. You have your runway analysis and flight planning right now. Again, all three solutions will talk to each other, will check each other, and that's really the strength of the ForeFlight solution here.
Okay, another question here for Josh. Why should I use runway analysis versus FMS data when the FMS allows a heavier takeoff or landing weight?
So runway analysis is all about safety. FMS is giving you simple certification requirements for takeoff or landing. Runway analysis is giving you obstacle terrain, close-in obstacles, avoidance. So really, it's apples and oranges. The AFM or FMS data is a starting point, but runway analysis is allowing you to make this takeoff or make this landing safely. There is absolutely, departing Aspen, there's no doubt you're going to be able to depart heavier in some cases by using AFM data, but you have to remember it's not considering any climb gradient requirements other than the minimum required per certification. So runway analysis is what I believe you should be using if you want to operate safely. AFM is what you should be using if you want to operate only within the certification guarantees.
Awesome. Thanks, Josh. I think we're going to go ahead and leave it at that. I will say if any of you have additional questions about this, and especially the future weight and balance integration, feel free to email sales@foreflight.com, and our sales team may be able to provide some additional information about that. But given that it's a feature that is not yet available, we generally don't share too much about that because things are still in development and still changing all the time. So I think we'll go ahead and leave it at that. Thank you everyone for joining, and thank you Michael and Josh for the great presentation, and Tyson. Of course, Tyson wasn't able to be here for the Q&A, but it was great having him on the webinar itself. Obviously, as you can see on the screen, if you're interested in purchasing Runway Analysis, just go to foreflight.com/buy and make sure Performance Plus is selected, and then you'll be able to select any of those aircraft models. If you're part of a business account, like I said, you can email sales@foreflight.com, or just go to that foreflight.com/RWA-form, and you'll be able to fill out a form we set up that goes straight to the sales team, and they will get back to you. Any support for Runway Analysis, you just go to foreflight.com/RWA-support. And of course, you can register for more webinars. The recording of this webinar will be available at foreflight.com at that URL you see at the very bottom of the screen /on-frequency. Check in about tomorrow, and if you go down to the part of the page that says past webinars, this webinar will be available at the top of that. So just wait a day, and you can share this with your pilot buddies and anyone else you think would be interested in watching it and would benefit from learning about this new runway analysis capability. So thanks so much, everyone, and we'll see you on the next webinar.